In this tutorial, I want to talk about relative molecular or molar mass, which has M capital subscript R. I also want to talk about Avogadro's number and do some related calculations. Just remember 1 mole is equal to 6.02 times 10 to the power 23 particles. Now these particles are either molecules, atoms, or ions. So the first question I want to look at is what is relative molar mass of water, and then what is molar mass of water. M subscript R H2O is challenged. For a question like this, you go to the periodic table and sum up all the atomic masses of the elements within the compound. We have 2 hydrogen. Each hydrogen is 1.01. Plus, we have 1 oxygen. It's 15.99 or 16.00. Sum it up, you get 18.02. Since it's relative, it has no units. Now, if you challenge me on molar mass, I simply use the same number, except this time I report it as grams per mole, written as gram times mole to minus 1. So that's molar mass with unit, relative molar mass, no unit. Now, the second question is what is mass in grams of 1 molecule of water? We know 1 mole, and in this case it's water, it's 6.02 times 10 to the power 23 particles. Now in this particle you have 2 atoms of hydrogen, 1 atom of oxygen, so it's not atoms, it's rather molecules. Well, let me just write it nicer. So it's molecules of water. We also just calculated 1 mole of water is 18.02 grams. So it's equal 18.02 grams of water. Now let's see what I can use from these known quantities in order to solve this problem. What is mass of 1 molecule? So 1 molecule of H2O. What is mass in grams? So you don't mind if I put variable of x grams. Then from these quantities, I don't need mole, but I need molecules and I need grams. So I'm going to use them. Under my molecules, molecule of H2O, I put 6.02 times 10 to the power 23 molecules of H2O. Under grams, I put 18.02 grams of H2O. This is creating a proportionality. Now these 2 ratios are equal. What you need to do is cross multiply and you can solve for x. These 2 quantities multiplied is equal to product of these 2. 18.02 times 1 is 18.02. 6.02 times 10 to the power 23x is 6.02 times 10 to the power 23x. Now for sake of multiple choice you have no calculator, so try to crunch numbers if you don't mind. So without calculator, to solve for x, divide both sides of equality by 6.02 times 10 to the power 23. 6.02 times 10 to the power 23. Since I always like to write my value on the left hand side, I put x here. And the second ratio, I write it as 18 divided 18.02 divided by 6.02 times 10 to the power 23. Now 18 has 3 sixes in it, so if you don't mind, the numerator is approximately 3, and I put a couple of zeros after decimal places to save significant figures. So 18 has 3 sixes, denominator becomes 1, so you have 3 divided by 10 to the power 23, and it's simply you can bring the exponent from denominator to numerator, just change its sign. So it's 3 times 10 to minus 23. And what's the unit? The unit should be grams. So 1 molecule of water is equal to 3 times 10 to minus 23 grams. So that's your final answer. Then again, try not to use calculators and simplify numbers. Looking at the third question is how many molecules do I have in 9 times 10 to minus 2 grams of water? Now then again, we remember that 1 mole of H2O contains 6.02 times 10 to the power 23 molecules. and it's equal to 18.02 grams. These are equal to each other. So for sake of this problem, then again, I need molecules versus grams. So I'm going to put the quantity of grams under grams, which is 9.02 times 10 minus 2 grams of H2O. And they challenged us as how many molecules you have, so X molecules. Now we are going to cross multiply these two quantities, should equal these two quantities across from each other. 18.02x is 18.02x. 6.02 times 10 to power 23 multiplied by 9.02 times 10 to minus 2. Divide both sides of equality by 18.02 in order to express it in terms of x only. So x is equal to this 2 multiplied divided by that. Now 18 has 3 6s in it approximately, so 3, and this is 1. And 9 has 3 3s in it, so denominator becomes 1. And numerator, you have 3 times 1 times 10. When you multiply exponents, you simply add them up. So it's 23 plus minus 2, which is 23 take away 2. So this is equal to 3.0 times 10 to power 21, and you put your units of molecules of H2O. Extremely small quantity of grams, it's 9.02 times 10 minus 2, but humongous amount of molecules, and this is really equal to give and take about 2 drops of water. The last question I borrowed exactly from IB, and this time I gave you the choices. You can multiple guess, but I want you to solve for it. How many moles do you have in 1.8 times 10 to power 22 molecules? Now let's see what we remember. We remember 1 mole of water is equal to 18 point, well, instead of that, let me just write Avogadro's first. Is equal to 6.02 times 10 to power 23 molecules. It's also equal to 18.02 grams, but I don't need that quantity, so this time I won't write it. Now let's just use what we have in the question. How many moles do you have? So it's X moles of H2O under mole, and this time you have 1.8 times 10 to power 22 molecules of H2O. Cross multiply again, solve for X. Your ratio looks good. You have like terms under each other. 1.8 times this is equal to X times 6.02. So 6.02 times 10 to power 23x is equal to 1.8 times 10 to power 22. Divide both sides of equality by 6.02 times 10 to power 23. They go away, so finally you have your x. Now I'm going to borrow a 10 from the exponent and make my ratio a little bit easier. So it's 18 times 10 to power 21, 10 to power 21, divided by 6 times 10 to power 23. 18 has 3 6s in it. So this is 3 times 10 to power 21 divided by 10 to power 23. When you have two exponents as a division, you subtract the exponents. So this is 3 times 10 to power 21 take away 23. So final answer is 3 times 10 to minus 2. Now this means take 2 decimal places to the left. So your final answer really is 3. 1 decimal place, 2nd decimal place, put your 0, put your digit. So it's 0.03 moles. And then pick and choose the right answer, which is B. Do not lose points. Try to solve stoichiometry. Until next tutorial.